valve when releases, the gas will be going from here to here, the motor get overheated, after some time it will be tripping. But we need to find out the reason for very high discharge pressure and solve it out. Yeah? The compressor don't fail, compressor will be not pumping, it will switch off because it got overheated. You have to wait for some time, motor has to get cooled before you start it and before you start it. Yeah?
I have a question please.
Yes.
This one available for all types?
No, the IPRB is only up to 5 HP capacity, 5 tons capacity, up to 5 tons. Yeah.
Again, please again.
The internal pressure relief valve is only available up to 5 tons capacity, like 72, up to 72 it might be available, not beyond that.
Okay.
Yeah. The smaller compressors, generally people may not use the HP cutout, like 2 ton, 3 ton compressor people may not use HP cutout. That's why we have this additional protection. If when it comes to more than 6 tons, people use HP cutout, so that will be taking care of this. You don't have this in bigger compressor. It is not a required, like smaller compressor, yes, we have this. Yeah. So this we call the IPRB, internal pressure relief valve. Okay. So I just this we would have seen, like the TWD motor has this motor protection. It has a winding thermistors. So this will be taking care of this winding as well as the discharge. It will be taking care of all this. When the winding temperature increases or a discharge temperature increases, this will be switching off. Yeah. So these are external, we call it external inherent protection we call. So it's a TW motor we have like this. Then you have TE motors also, that is with the core sense, that also very similar. When the winding temperature increases, it will be giving the signal to the contactor to switch off. Because the control circuit need to take it through that. But we found in a lot of sites like people bypass it. Once it trips, they bypass it and run it. So finally the compressor could fail because of that. So whenever it is tripping, you need to find the reason for tripping and you need to solve that instead of like bypassing this. Yeah, you need to take care of that. So I'll just quickly give you a thing on advanced cold temperature protection. This protection is there for 7 ton to 15 ton capacity, up to say like 182, 183 sort of a compressor range. Yeah, up to 182 you have this protection. One advantage is it cannot be bypassed. Eliminate discharge line thermostat. You don't need a discharge line thermostat separately. It can reduce the warranty cost and all that. What happens is the discharge line temperature of the compressor or any refrigeration system, air conditioning system is very critical. When the discharge temperature goes beyond certain limit, it will be breaking the oil. Whatever oil you have inside, the POE oil or a mineral oil, when the temperature of the oil reaches beyond the limit, then it breaks. Chemically it breaks, then it won't lubricate. So the compressor will fail. So it is not about refrigerant, it is about the oil. Refrigerant, no problem. Even if they go to high temperature, nothing will happen to the refrigerant. But the oil being used has a limit up to which what temperature it can go. So that's why we have a discharge line temperature protection for all our compressors. This particular compressor also we have a similar discharge line temperature protection. So this cannot be bypassed, reduce warranty rates and all that. I'll just show you how it works. So we have seen the earlier thing. So this is fitted in the intermittent pocket. There is a pocket, intermittent pocket in the scroll compressor. It is fitted here. So based on the intermittent pocket only, the scroll contact is taking place. If the pressure reduces in this pocket, the scroll contact don't take place. The pressure actually maintained, then the scroll contact will take place. So this intermittent pocket, we have a bimetal disc. We have a bimetal disc here. If the temperature increases, this bimetal disc opens and allow this pressure to reduce. It will be bypassed, so the pressure reduces. The scroll gets separated from each other and it won't be pumping. So this can happen during commissioning also. So we said earlier, any scroll system when you are commissioning, 70% of the gas, you have to put it as a liquid on the liquid line before starting the compressor. We are seeing people who are charging little bit of gas and start the compressor and start charging. What's happening? When you are doing that, your discharge line temperature also goes very high. When the discharge line temperature goes very high, it will stop pumping. The compressor doesn't pump. They say I am commissioning the system. It was pumping initially, then it stopped pumping. It is because of this protection, ASTP protection. So you have to ensure that 70% of the gas is charged before you start the compressor. Yeah. Even while running, if you are not maintaining proper superheat is very high, or discharge pressure is very high, there is a possibility your discharge line temperature is very high. That time also, it will be stopping pumping. It will be stopping the pump. Yeah. We'll just quickly look at this. We have a small video as well for this. This is a bimetal disc we have. When the temperature increases, it will just open. It will bypass the intermediate gas outside. to the suction. So when it is bypassing, the contact between the orbiting and fixed scroll is not maintained. The tip-to-tip contact is not maintained. Yeah, when tip-to-tip contact is not maintained, it won't pump. It will be just running without pumping. Yeah. So this has a bimetal disc which could open. Sorry. The bimetal disc open when the discharge line temperature reaches around 310 plus or minus 25 degree Fahrenheit. It's approximately like you can say around 150 degrees centigrade. When it reaches around 150 degrees centigrade, this will be opening it. Yeah, the compressor unloads but continues to run. When it opens, what happens is compressor will be running, motor will be running, but there won't be any pumping. So people come back. I get a lot of calls from site. They say like compressor is not pumping. It is everything is okay. Compressor not pumping. So there is a main reason could be this ASTP tripping. So when the ASTP is coming to picture, so what you need to do is whenever your compressor not pumping, you have to switch off. Wait, let it cool down. Then you switch on again after 1 hour. You have to give at least 1 hour gap. Yeah. After 1 hour you switch on. If it is start pumping, right, which means the ASTP has tripped earlier. So ASTP has stopped the pumping. So that is due to your very high discharge line temperature. That you need to correct it. That could be your choke somewhere, choke in the filter dryer, or choke in the expansion valve, or expansion valve is not maintaining proper superheat. The superheat is very high. Your suction line temperature is very high. So that can lead to this. Yeah. So you need to take care of that. So when it is like when it is running without pumping for some time, the motor also gets overheated because motor is cooled by the gas which is coming back. When the gas is not circulating, the motor also gets overheated and it will be tripping. The motor will be tripping. The compressor turns off. Alright. Then the motor protection resets. When the compressor switches off, after some time, the motor protection resets. When it resets, again it will be start pumping. So whenever you have a problem with not pumping, switch off the compressor. Wait for 1 hour, again switch on. If it start pumping, this is the issue. Your discharge line temperature is very high, that need to be taken care. Yeah. So that, as I said, this could be related to very high superheat. Your expansion valve need to check. You have to adjust the expansion valve, or you not put the bulb in a proper location and all that. Everything you need to look at. Yeah. So these compressors are like this particular protection is available from Jadar 84 to 144. We have in bigger models also, up to 182 as well. Yeah. So whenever you have this compressor and you have this sticker on the compressor, sorry, sticker on this compressor. So this will say advanced cold temperature protection. Compressor may stop pumping with motor running. Turn off and wait until cool. May need more than 1 hour to reset. Right? If you have this sticker and the compressor is not pumping, you wait for 1 hour. Don't declare compressor failed. It is a waste of your time, waste of money, right? When you are replacing the compressor, gas you have to replace and all that. Don't get into it. Just wait for 1 hour, cool it down, again switch on. When it starts pumping, which means it is stripped because of ASTP, that we need to find out why the discharge line temperature is going up. It could be very high superheat, could be one of the reasons it can go up. That need to be taken care of. Or if you don't have sufficient gas charge, the discharge line temperature goes up. Yeah, because of very high superheat. Yeah, it can go up. Just run a quick video.
Copeland Corporation, a division of Emerson Climate Technologies, is introducing advanced scroll temperature protection, a breakthrough development in internal discharge temperature protection on its 7 to 12 horsepower commercial scroll compressor platform. With advanced scroll temperature protection, the compressor's scroll elements actually unload, stopping compression when high temperatures are observed. The technology is completely internal, meaning there are no wires or sensors to deal with, and the device cannot be bypassed, a common cause of failure in compressors with external protection schemes. Advanced scroll temperature protection is made possible by the unique design of Copeland scrolls. In normal operation, compression forces try to push the upper and lower scroll elements apart. Copeland scrolls use a pressurized cavity on top of the upper scroll in order to provide just the right amount of hold-down force to keep the scrolls together. In compressors with advanced scroll temperature protection, a bypass hole has been added between this cavity and the suction side of the compressor. A bimetal snap-acting thermal disc blocks this opening, similar to a valve. When this disc senses excessive temperature, it snaps open and allows the pressure in the cavity to escape to the suction side of the compressor. As the cavity pressure drops, the hold-down force on the upper scroll is eliminated, allowing the scrolls to separate. This stops compression and allows internal temperatures to decrease, although the motor continues to run. In other words, the compressor will run, but will not compress gas. Suction and discharge pressures will balance. To reset the thermal disc, stop the compressor and allow it to cool thoroughly. If the compressor is allowed to run, heat will build up in the motor, causing the compressor to shut down on motor protection. Keep in mind that the longer the compressor is allowed to run unloaded, the longer it will need to cool in order to reset. If you find a compressor that is running but not pumping, it is likely that advanced scroll temperature protection has activated. Do not assume the compressor has failed. Turn off the compressor and allow it to cool thoroughly, which may take a half to 2 hours. Then restart the compressor and verify that it is operating normally. In this example, watch as the internal temperature reaches 275 degrees Fahrenheit. The bimetal disc will snap open and the compressor will unload.
So you can change in sound also, you can see. You see the change in sound as well. You see the current
Note
also.
that the pressures have balanced and the internal temperature is now decreasing. This unloaded condition will continue until the compressor is stopped and allowed to cool. Because it is internal, automatic, and cannot be bypassed, advanced scroll temperature protection will prevent compressor overheat failures that are often the result of system malfunctions, low suction pressures, or misapplied temperature protection systems. Remember, the compressor that is running but not pumping suggests a protected compressor, not a failed one. Look for the Advanced Scroll Temperature Protection label to determine if the system you're servicing has this internal protection technology. For more details, visit us on the web.
We over the time as well now. I know, like, it is a late lunch or early dinner, whatever way you want to take. And we'll just stop here. If you have any questions, you can ask me. Or you can ask me questions when we are around the lunch dinner time as well. Yeah. If you have any last questions, you can ask me now, or we can just catch up with this thing.
Okay.
Very exact equivalent. Go for a little bit lower, no problem.
Select less and equal to zero.
Huh?
I selected less.
Yeah. It is okay to use a little lesser compressor. Yeah? If you don't have an equivalent, go for a next size lower compressor. You should work okay. Okay. So, any other question? You're free to ask questions when we are there for lunch come dinner.
Yeah. Okay. Thank you.
Okay, if you don't have any questions, then I'll give the mic to Mr. Ali.
Thank you, Mr. Rai. Thank you very much. Again, I will thank you all for coming. We have invited you on a very short notice. We know you guys are busy, and we took you out of your work and out of your schedule. Really, thank you very much. And if you need anything regarding Copeland, you can contact us at any time. You guys have my contact numbers, my colleagues also. Anytime you have any questions, you have even advanced questions, we can go back always to Copeland gentlemen at any time. And thank you again for coming, and please do not leave before having lunch.
Yeah, thank you. Thank you.
Thank you.
Thank you.